Our platform, OpenStudy, is a digital teaching and interactive courseware management system. Its core product logic aims to lower the threshold for creating immersive educational content by integrating standardized dynamic interactive components with large AI model capabilities. First, let's look at the architecture for OpenStudy. As you can see, the system is organized into 4 main blocks. On the front end, we use React 18 with TypeScript, bundled by Vite 6 for high performance. We've adopted a component-based design, using Radix UI and Framer Motion to ensure a seamless, accessible user experience. The backend is the brain of our platform, powered by Python 3.11 and FastAPI. It's structured into 3 layers. The API layer handles RESTful requests. The service layer manages business logic like automated grading. And the model layer uses Sclalchemy and Pydantic for robust data validation and/or management. For data management, we use a hybrid strategy, PostgreSQL via Supabase for rapid development and MySQL for our production target, and our AI module connects to large language models through the OpenAI SDK. One of the technological innovations is that OpenStudy's lab generation module is a small agent system with autonomous review and error correction capabilities. It not only enhances the success rate of component generation, but also lays a solid technical foundation for the subsequent expansion of more complex teaching scenarios. Welcome to the OpenStudy lab demonstration. Step 1. Creation. Open the AI assistant in the Drafts workspace to generate a lab draft from scratch using natural language. When a specific command is entered into the AI assistant, such as generate a simple experiment to demonstrate the process of photosynthesis in cells, the underlying agent of the system will parse the core semantics in the user's input, trigger a self-reflection process, and construct CVG rendering code in real time. After having a clear understanding of the core elements of the experiment, the agent will immediately render the interactive components and dynamic processes of the experiment in the preview area and automatically generate a parameter control panel to adjust some changes in the experimental parameters during the whole process, and display the content changes of other dependent variables during the experiment. Let's switch to the driver mode. Taking this physics circuit experiment as an example, you can adjust the interaction status using text commands without modifying the code. The system also supports directly importing the experiment-specific JSON configuration files saved on the local host and allows for custom personal optimization and re-importing into the database, achieving a high degree of design freedom. Step 2. Cataloging. Click Publish to add the draft to the asset library, allowing other teacher users to preview and use the experiment to assist in teaching. Here, multi-dimensional filtering operations for the lab are provided. After confirming that there are no errors, you can click the button in the upper right corner to integrate the lab component into the teaching scenario enhanced by PPT. Open the component library in the slide editor. Teachers can insert existing labs or system templates. Components are embedded directly and can be laid out alongside standard content like text and formulas. Step 3. Lesson Management. Clicking on Present under the lesson interface will enter the full-screen teaching mode. Thanks to the native embedding technology, teachers can directly operate the experiments within the slides during teaching. The experiments support highlighting display, ensuring a dynamic interactive classroom centered around the lab. The Edit function allows for personalized adjustments to the layout of the PPT content, free scaling of the experimental components, and adjustments of the text and components on the layers. Sustainability is achieved by saving in the database.
The assessment feature of our app OpenStudy. There are 5 modules of this part, and I'm going to show you one by one. So let's take a look at the AI question generation. Well, let's start with the upload doc. We can click here and choose a doc. We can choose the question types and their quantity, and decrease or increase. And also we can choose difficulty level here. So I think the coolest is we can generate some question illustrations here. So let's choose multiple choice. Right, then click next and click generate. And I'm going to show you the original doc. Yes. So let's wait a little time. Okay, let's take a look at the generated questions. Yes, so we can see it has the appropriate illustrations, can help the students to choose to make a right choice, and it's just like the original doc. Okay, then let's come to the end of the test. The composition of blood cells, principle of photosynthesis, principles of respirations. Alright, then we have those questions close to those knowledge points. Okay, let's take a look at the third content, the test book. So we have publisher, grade, subject, and semester in here. And the same step. Okay, let's take a look at the questions. Alright, those questions exactly from knowledge point. Then we can save all and create question bank. Yeah. Okay, let's take a look at the fourth content source. So let's upload. We can take comparison. We can see the generated questions have the basically same knowledge point in there. Then let's look at the last content source from questions. We can generate from the existing questions. Yes, you can see. Let's take a look. You can see those questions. These questions is closely resemble the original questions. Okay, let's look at the AI paper module. In step 1, we select the exam type. We have midterm exam, final exam, unit test, special practice, review test, and contest mock. Let's select the midterm exam. Then we can see the test exam. We can save the drafts and export PDF. In question bank, we can filter the questions with subject, grade, semester, difficulty, and question type. Or there are no multiple choice, then we can add one. Okay, then we save the bank. Okay, we can see the question we just add in here. When we set it, then we can see all of the questions. And let's look at the exam paper banks. So we can see we use an intuitive copy-paste system, so metadata like subject, grade, semester, type. It's very easy to read at a glance. Plus, with the powerful multi-level filters on the left, you can find exactly what you need in seconds, just like the question bank. Let's look at the core feature here, a small PDF phrasing. Let's choose a PDF. It's just the questions and turns them into clean, structured digital cards. You can tweak the text on the left here and watch the real-time formatting update on the right. And then let's take a look at the last module, task publishing. Basically, you can make your own exam paper in task canvas. Then we can save draft. Then we click publish. Okay, and then we can choose assignment type. Exam, quiz, homework. We choose exam. 30 minutes. And we have time limits. We have the schedule. We have the assigned to classes. We choose grade 9 8. We have two options: show results to students after submissions, and allowed late submission. So we do not choose these two because this is an exam. And publish now. Then we see it has been published. Yeah, this has been published. And back to the exam. So it's basically the task publishing.